8.2, problem solving in geometry with proportions. So we talked about proportions in the last section, and there when two ratios are set equal to each other. So the properties we're going to start off with talking about. Here's the first one. When we start off with a regular proportion, A over B equals C over D, then A over C equals B over D. So what we did was, in this property, where these two switched positions. And why does that not matter? Well, if you think about your cross products, you're still taking B times C. Just like over here, B times C, A times D. Your cross products for all these properties will be the same. Okay. So when you're looking to see if two proportions are equal, check to see if the cross products work out to be the same. This next one gets a little bit more complicated, but the book goes right from here to the answer down here, and I'm going to fill in this answer in a second. But if you look at this, A over B equals C over D, it starts the same. Well, what if we add 1 to both sides of the equal sign? One thing you might, if you remember adding fractions, we want to add a fraction and a whole number. We're going to get a common denominator. That denominator in this case would be B. And on this side, we'd need a common denominator of D. D as in dog. So if we change this 1, and sometimes I like to make big ones here to show that this is 1. We're still adding 1, but we changed it so that we had a common denominator. And now, when we add these together, I get A plus B over B equals C plus D over D. So you're adding 1 to both sides, but it's going to be a different number in the numerator in order to keep it 1, right? B over B is 1. So let's look at these and decide whether they're true or false. A over 4 equals B over 8. Well, does A over B equal 1/2? Well, you look at your cross products, you look at this, you say, is 4B equal, if 4B equals 8A, look at your cross products, how about 2A, does that equal B? And you look at that, well, you had twice as many A over here as here, you have twice as many A's over here as here, that would be true. So I looked at the cross products. Now, what they did was they switched these two around. That's that first property. We can flip-flop those. So then it was 4 over 8, and then they just reduced that 4 over 8 down to 1/2. That is perfectly fine to do. This one over here, A over 2 equals 3 over 8. Does A plus 2 over 2 equal 5 over 8? So I notice by adding 2 to the numerator here, I was really adding 1. So if I add a 1 to this side, I'm not going to add 2 here. I have to add the denominator. So that last property, if I add 1, what do I have to do to the other side? I have to add 1. In this case, it's going to be 8 over 8. Right? This one was a 2 over 2, right? That's why we have A plus 2 over 2. Here we're going to have 3 plus 8. We want 11 eighths to be this number. So this one would be false. Okay. You could also, here you have one variable, so you could technically check your cross products, solve this thing, and see if it actually is a legitimate, does A equal the same thing in both parts. It would need to in order for it to be true. Now in this diagram, they show us that this proportion is equal. find the length of LQ. We want to find that number. So we're going to have to, LQ is what we're looking for. So I put a variable in for LQ. LP is 5. MQ, from M to Q, is not 6 and it's not 15. It's the total length, right? 6 plus 15, or 21. And MN is 6. And if you look LQ, basically they're using similar triangles to set up this proportion. But this big triangle is proportional to this littler triangle. And then we'll talk about later why these shorter parts are actually proportional too. But from here, we look at our cross products. Since I'm not doing the stuff with the calculator, I'm going to reduce this down ahead of time. I know 3 goes into both of those, so I get 7 halves equals x over 5. And now I get 35 over 2 equals x. My cross products, 7 times 5 divided by 2. And you can leave it like that, or you could figure out how many times 2 goes in there. 17 and a half. The geometric mean, okay, is different than an arithmetic mean. A geometric mean is more to do with side lengths. Basically, you're looking for the geometric mean of 2 numbers. Here's a shortcut formula. This is my formula for it. You can just do this formula, put it in your notes. It's different than how the book describes to do it. What the book describes is, if you're looking for the geometric mean between A and B, they want you to set up A and B in the extremes and x in the means, and they say solve for x. Well, you're going to get x squared equals a times b. And well, how do you solve for x? You got to take the square root. And so lo and behold, every single time you do this, you're going to follow the same pattern and do that part. So if we're looking for the geometric mean between 8 and 12, you'd take 8 times 12 and then take the square root. 8 times 12, 80 and 16, so 96. Square root of 96. Well, we need to, as this chapter gets going, we need to know how to simplify square roots. Okay, and to simplify square roots, you want to break it down into square roots of perfect squares and square roots that are not perfect squares. Looking at this, I know 4 right off the top of my head goes into 96. So 4 is a perfect square. I'm checking my perfect squares. Like 1 squared is 1. That's a perfect square, but it's not useful in this case. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And usually when you're simplifying them, you don't get much past those. But these ones you do want to have memorized. Okay, memorized, recognized. And I know 4 goes into 125 times, 4 goes into 96, then 24 times. Then I ask myself, does any of these numbers go into 24? Well, they don't. So the square root of 96 can be broken into the square root of 4 times the square root of 24. Well, what's the square root of 4? The square root of 4 is 2 times the square root of 24. So I actually did this operation, right? The square root of 4 is 2. I did that operation. When I do that operation, I take the square root sign out. Just like if I said, what's 10 divided by 5? The answer is 2. I don't leave it as 10 divided by 2 now, right? I divided by 5. That part's gone. I get my answer. Square root of 4, my answer is 2. Okay? A lot of people get confused on that part. So this would be my simplified answer. Last example here. Just kind of a real life situation. A scale model of a C-17 is 1 to 10. If the model has a wingspan of 11 feet, what's the wingspan of the real plane? Well, we're going to take that ratio, 1 to 10. A scale model of a C-17 is 1 to 10. It's the model to the actual. So when we come over here, if the wingspan of the model is 11 feet, well, if we put model up here, this is the actual, we got to follow the same thing on the other side. So the model was 11 feet. What is the length of the actual? Once again, cross multiply, divide, we get 110 feet wingspan. There's the homework. If you got questions, bring them to class and let's ask them. See you then.